Well, there we go. Never mind. All right. My name is Andre Roberge. I am in the Air National Guard in Washington State. I've been full-time there for about 2 years. I've been doing mainly a help desk role until around February of this year, where I moved into an infrastructure support role. I'm CCNA ×3. I got 3 associate CCNAs last year. Focused on associate level because I wasn't even in the field yet. So I wanted to get like a wide, understanding of everything. I've been in infrastructure since about February, but we've been doing COVID stuff, so I haven't been too involved. And I'm supposed to be moving into a network security role starting next month or the month after. But anyways, that is a little bit about me. This course is about Cisco SD-Acess. And this course would be most beneficial to people that are studying for ENCOR and haven't yet reached SD-Acess, so they can get a little bit of an introduction to what it is, what it entails. And today specifically, I'm going to cover what you have to automate or what you are automating. Didn't really have time with my foot surgery and everything to get into DNA Center and Identity Services Engine. So today I'm mostly going to talk about the overlay and underlay and what SDA consists of and why they kind of built the solution the way they did. You'll notice also if you start studying for SDA that it's basically all over the exam blueprint. I mean, it's explicitly here in the slide as 1.5.A and B, but if you look elsewhere in the blueprint, there's DNA Center explicitly, there's MAC authentication bypass, controller-based, WLC, Lisp, and Vxlan are explicitly in a different part of the exam topics, IP services, RESTconf, 802.1x. So, I mean, once you start studying SD-Acess, you can pretty much start studying about 50 to 60% of the exam. I think the best place to start for studying SD-Acess is to study, like what I said in the intro, what you will be automating. And then to do that, I think it's best to study like why we chose a routed access versus switched access. Here we have your classic core distribution access layer. And, as I was studying for the switch exam last year, you have lots of different ways you're trying to get around SDP, but like SDP is the biggest thing you are, trying to get around. Like if you just had classic SDP, like one of these guys here would be, your active root for SDP. And then that would also be like the first hop for your little guys down here, your little hosts. And then you could have some sort of failover where, if this goes down, then this is your secondary. And all sorts of ways, like you could do it where you have like half your VLANs on one of your distribution switches, half of them on the other. And then you correlate that with your, primary and secondary route. Anyway, there's a lot of control plane stuff you have to take care of if you're going to implement, a spanning tree design. And let's see here. Dun, dun, dun. Excuse me. All right, so yeah, there's first hop redundancy protocol, MLAG, VSS, HSRP, setting up your primary and secondary routes. But for routed access, you're going to make the demarcation for the layer 3 right here. So all your hosts coming below are still going to be connecting via layer 2. And then everything above here is going to be able to use equal cost multipathing. You're going to have IGP connecting all these ports. And so you won't have to worry about convergence. It'll all be under one control plane via the IGP. So it's a lot easier to manage. You can use things like traceroute and ping in order to troubleshoot. No need for HSRP anymore. And then the other main process, like I said earlier, that the host's main like default gateway is usually at the distribution layer. And then when you switch to routed access, you bring in the concept of Anycast Gateways. So this figure on the left here, this is basically the last slide that I was trying to explain how a host connects to your distribution layer to get their IP services. And that's, anyways, sorry. And in an Anycast gateway situation, each single switch on the edge here is going to have the same exact configuration. For each subnet or VLAN, it's going to have an IP address and a MAC address, and it's going to be the same on each switch. So no matter where your host moves in the network, they can move from this switch to this switch, and they don't have to change any default gateway information on their device. They just connect up like they were connecting to the previous switch. Nothing has to change. The config is simpler. It's easy to replace, like if you have to replace one of these switches, and yeah, easier to config. Let's see. And then let's see what my next slide is here. Routed access. What else do we need to do? So if these guys are on the same VLAN and they want to talk to each other over routed access fabric, they're not going to be able to, because once you hit layer 3 here, this solution is not natively going to support being able to get this host traffic over to here if they want to talk to each other. So the next thing that we have to do is that we need some sort of overlay that will carry our layer 2 packets across the routed access. And to do that, we use an overlay. I guess there's like some other data center technologies that can do this. Like, I don't know if they're still in use, like Trill and Fabric Path. But the common thing that we use now is Vxlan. Vxlan encapsulates, so this would be the entire original layer 2 packet from the host, and Vxlan is gonna encapsulate the entire thing, add its own headers, and then it carries it across the layer 2 fabric, and then that VLAN tunnel endpoint will then strip off all of these and then deliver it to the end host, as its original layer 2 packet. So VLAN to the rescue. VLAN by itself supports a flood and learn control plane. So if we go back to the previous slide here, let's see. If this guy is sending an ARP to get this guy's IP address, this guy, if he doesn't have it in his cache, he's going to have to send out a broadcast, basically, which will be put on the multicast group of everybody in this VLAN. So he's going to flood it out, and hopefully, this switch will see it and be like, oh, he'll flood it out here, and he'll reply, and then he'll have it in his cache. But it's a flood and learn. So if you have like a really big network, you don't necessarily want to do flood and learn. You're trying to get rid of that with the layer 3 access as well. So on top of Vxlan, let's see. Dun, da, da, da. Dun, da, da. Oh, here I got a nice little thing. So I guess I could have done what I just explained on this slide. Sorry about that. Here we have each edge device in Vxlan is known as a Vtep. This is still layer 2 down here. We're going out layer 3 with the encapsulated Vxlan packet. And then what else do we need to get rid of flood and learn? So Vxlan is good for tunneling our layer 2 traffic over the layer 3. And then once we do the flood and learn, it's unicast after that, but we still don't want to do flood and learn. So the most popular way to do this is multi-protocol BGP, but in SDA, we do not use multi-protocol BGP. Let's see, I was talking to a Cisco SDA guy on Twitter, and he said it had to do with multi-protocol BGP as a push method. So if it learns a route, it's going to push it out to every endpoint. And that's still like too busy if you have a big network. So they use Lisp, Locator ID Separation Protocol. And with Lisp, it's a pool method. So let's see if I have a, here I am. So it's a pool method. So if you got your little guys off your edge nodes here, it creates EID to RLock mapping. And this is a control node. So when an edge device tries to get on the network, it's going to receive an EID to RLock mapping. This guy's going to go, do I have this? He'll be like, no. He's going to come up here, register this EID. This person's going to put it in its database, and then say this guy over here wants to send a packet. He's going to do a query to find out what is the EID to RLock mapping. And that's how you create the control plane in SDA. So let's see if I can explain that better. Dun, 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 dun. Dun, 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 dun. So yeah, this can be split into two different devices to be like modularity. Like if you have a really big environment, one device can be used for registering and one device can be used for doing the mapping, like answering all the queries. But let's see, this edge device is now going to be a Vtep, you know, in Vxlan terms, and RLock in Lisp terms, and a border node, or no, these are edge nodes, an edge node in SDA terms. So let's see if I can put this all together in one thing. Dun, 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 dun. Give me 1 second. I don't know how to erase them all at the same time. So we can pretend now that we have, I guess I can talk a bit about the underlay here too. Put some intermediate nodes here. So these are also nodes that are within the fabric. These guys are only going to be part of the IGP, the ones I just drew in red. Each device here that you see for the IGP, oh shit, for the IGP is going to have to, let's say, you can use OSPF, EIGRP, or ISIS. If you use DNA Center to do the automatic configuration, it's going to do ISIS. And every node in here is going to be connected via a point-to-point link. And then each node needs to advertise, you know, their loopback address. So within the IGP, you'll have, you know, .3 and .4, and then you also have to do this guy's, well, I'm hitting it with my thumb. You have to do this guy's loopback address. So everybody has to advertise their loopback address, and you have to have IP reachability with everybody's loopback address within the IGP. And then try and do a tiny packet walk here. This guy's going to want to send a packet all the way over to this guy. It's going to look in Lisp, the control plane, to see if it has a power lock to EID mapping. If it doesn't, it's going to query this control node, and this control node will reply back with the RLock that this EID exists on. From there, it'll put the Vxlan header information to encapsulate this guy's entire layer 2 packet. And then it's going to use the destination IP address as this guy right here. This is the RLock from which this host hangs off. So as I was talking about earlier, all these intermediate nodes in the middle, they do not have to know any endpoint IP information. They only have to have IP reachability to the RLock. So it these guys don't have to be as beefy as a device. Their tables won't be as big, easier to scale. Anyways, so this guy sends his little packet on, this Vxlan, goes through the underlay, gets to this RLock. This guy, he's going to put this host over here, EID to RLock mapping once he receives it, when he's stripping off the encapsulation. He's going to strip it all the way off to the original layer 2 packet and then send it off to his host here. And that is pretty much the packet walk. The only other thing to mention is that, say this host over here wants to send a packet to someone that's not within the fabric, there's going to be a default route on each edge node here to send it to the border node. And then the border node is going to do like a conversion of taking it from Lisp. Let's see if I have that written down in my notes, what that's called. Yeah, I just have that it's a PXTR, so a proxy tunnel router. It's going to switch the Lisp fabric packet into something like the regular network on this side can understand. So all these guys have a default route. And then out here, to note as well, you'll have your DNAC, put a little N in there. You may have like connection to the internet out here. So these border nodes are what take care of that. And I guess to note here, while the DNAC is outside of the fabric, it's out of band management. So for if whatever reason you don't have connectivity to your DNA center, I mean, this is going to be able to run by itself for a long time. The only issue is if you want to change something via DNA center, you're not going to be able to do it, but your network's still going to be able to go. Let's see. Let me check out my notes for 1 second to make sure I didn't skip anything. So yeah, I guess the my reasoning for going through everything here. Let's see if I do done and bring it back. How did I get it out of here before? There we go. The reason I wanted to go through everything in the overlay and underlay is because I recently took a ACI Essentials class, which is the data center software defined implementation by Cisco. And they went straight into like logging into the APIC and doing things from the APIC. And for me, I think it's important to get an understanding of what you're going to be automating with DNA Center before you begin getting into how to do it through DNA Center, if that makes sense. You can do all of this manually, but the thing that DNA Center allows you to do is like set up IP pools, set up policies so that you can configure all of these devices, like in a greenfield deployment at least, automatically, no configuration. You don't have to worry about setting up, the point-to-point links. And I guess this is the last slide I got to for this. I wanted to get into more of like how these guys are going to help be the seed nodes and the PNP devices, and then how you integrate ICE with PX Grid for DNA Center. But I didn't really have time this week with my leg, and I studied the stuff, but I don't feel like I'm to a point where I can explain it very well. But yeah, that's pretty much all I got today. If anyone has any questions. See if I can get back to my face here. How do I stop sharing?
I got a question for you. First off, thank you so much for doing this. This was fantastic. And what resources did you use to go through all this?
Okay, sure. Let me see if I can see where you guys can see me again. Start video. I don't know, can you guys see me or no?
Yeah, we can see you.
Oh, okay. All right, resources. So I went through the new SD-Acess book. I probably read about 80% of it. The identity services engine stuff, it's a lot for me to take in. So those are the kinds of sections where I skimmed more than like read deeply. Chapter 6 of that book is very good for doing like the packet walk and kind of going into more detail of what I did today, as far as like what happens at each point and explaining like what you're doing at a protocol level versus like what you're doing in DNA Center. Let's see what else. The Cisco on-demand library. There's a few. There's probably like 10 videos, but all the slide decks for those are great. There's great design videos there to discuss like, what sort of devices you need in each spot, how many devices, how to connect them together. And then, let's see, there are a few people on Twitter to follow. Let me see if I can find who they are. We got Ananda, and then, let's see, there's one other SDA guy that he's one of the co-authors of the SD-Acess book. And he is very, like if you reach out to him, he'll talk to you. He'll answer questions. I'll have to give his name out later if you guys are interested. I don't know it off the top of my head. I'd have to look at the book. But, and also I have the, whatever it's called, Cisco Digital Learning now. And in the Cisco Catalyst 9000 course, there's one lab where you get to set up DNA Center in an SDA fabric, and they pretty much go step by step how to set up the integration, and then set up your seed switches, and then how to push configuration down automatically, and then how to do certain policies within DNA Center. So I only did that once. It took me about, I don't know, 3 to 4 hours. And I got to a point like 80% in where I couldn't get to the next step. But that's a good resource if you do have the Cisco Digital Library.
All right, Andre, I don't know if you caught that, but there's a question in the chat. I can read it for you if you'd like.
I got it.
Okay, there you go.
Let's say, since SDA is embedded in a lot of other topics, what topics, in your opinion, should a student be aware of? I guess, your layer 2 and layer 3 stuff, like I tried to go through, probably not very well, like how we got to the solution. So you can go through like your first hop redundancy protocols and everything to see like where we were at and then why we are implementing the solution the way we are. So I guess like you don't need to know ISIS, that's not on the blueprint, but understanding how layer 3 routing works. I guess that's pretty much it. Just like general like campus design, I guess if I'd read chapter 1 of the old Arch book, I think they came out like 2016. I'd read chapter 1 of that. That gives a good overview of routed access versus switched access, and it also has some other like data center stuff incorporated in that as well. But chapter 1 gives like a great overview of everything. So I guess if I do one thing, I'd read chapter 1 of the Arch book.
Yeah, the only other thing I'd add to that is I don't think for the ENCOR exam you need to worry about any sort of configuration of any of these. So you should understand, what is Vxlan at a high level, but don't worry about like configuring Vxlan because that's certainly not going to be on the exam. And that's not part of the DNA Center solution because that's DNA Center's job, right? Like when you have DNA Center do SD-Acess, it's doing all that for you behind the scenes.
Correct. And Lisp and Vxlan are in its own like separate part on the blueprint, but it is like explain, I believe. But it's just good to know like what their job is, I guess, and why they are there in the solution. And that's kind of what I tried to convey today.
Well, I ended up being on the road for part of this, but from what I caught, I think you did a fantastic job. You nailed it. Thank you so much for doing this. This is great.
All right, no problem. And I'll be doing the same talk tomorrow, hopefully a little bit more, more better since I had a little bit of practice. This is my first online presentation ever. So I have to get a little bit more comfy with like what I'm doing and make sure I'm, more linear. But if you want to attend tomorrow as well, if you're super bored, I can share that link with you.
But where are you doing it tomorrow?
So tomorrow is, let's see, how do I, dun, 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 dun. It is, how do you say her name? Diera, CCIE by 30. It's her study group.
Gotcha.
So there's usually only like 4 to 5 people, but we do it usually on a Wednesday afternoon. So I don't know if we'll get more people since it's a Sunday. This is our first Sunday session.
Very cool. You did a great job. You could have fooled me. I thought this was like a part-time job for you. You did a really great job presenting today. Appreciate it.
All right, thanks, AJ. Anyone else have any last parting thoughts?
Where did you learn how to do that?
I don't know. I think it's from a kid's show, like one of my daughter's shows. So I pick up on a lot of like the theme music or whatever from her shows. I'll end up singing it throughout the day.
I'm just playing.
But yeah, I used to always do sound effects too. I used to be like a barista and stuff, and I always did like sound effects with all my different, every time I did something, I had like a sound effect or like a little song. I tie a lot of noises into like what I do physically in the world. Same thing when I did some baking too, is the same kind of thing. I don't know why, but that's just how my brain works.
Here's a serious question though. What do you think about SDA? Is it a good solution, bad solution?
I think it's an expensive solution, I suppose. You can do it manually, but then you'd have to like worry about, I don't know, I feel like, so I've done a little bit of stuff with like Cumulus networks on the side, and they do, multi-protocol BGP, basically the data center version of this. And then they use Ansible to push out configuration to automate it. And I feel like you could do something like that with, lesser expensive equipment. But The point where I think the SD-Acess really shines is the identity services engine integration, where you have all of the security pushed out to your edge nodes. Like right when a device is trying to get on the network, like that's where the security is. I think that integration there is like the best selling point for SDA, in my opinion.
Yeah, I think one thing that you'll hear tossed around if you're learning about SD-Acess and ICE is the SGT. And depending on the business unit you're talking to or whoever wrote what you're reading, you're going to hear secure group tag and scalable group tag, and they're referring to the same thing.
Yeah.
So that threw me initially.
I think is like what really sells SDA
Yeah, for sure.
I don't know, more than DNA Center. I mean, because you can automate a environment in a lot of different ways, but I think the security aspect of it, and I guess perhaps the analytics and the assurance, I haven't looked at that too deeply, but that could be also valuable. But other things do that as well. But yeah, I would say identity services engine is, if I was going to sell SDA, that's what I would focus on most.
Did you look at the network DVR at all?
The what? Sorry.
So with all the analytics and stuff that you can do with DNA Center, they have something called, it's basically like a network DVR. So, you know, typically when a user comes to you and says, oh, at 3 o'clock yesterday afternoon, I had this problem connecting to the Wi-Fi with my mobile device, you can be like, well, that was yesterday at 3 o'clock in the afternoon. I can't really like troubleshoot that now. Well, you can with DNA Center because it stores all of those analytics because it's getting like real-time telemetry. You know, it's like between SNMP and like all these other sources, it's just pulling in all this data. So you can actually go back in time on your network and look at what was happening with that client connecting to the network at that time. And you can see, it's like, oh, well, she had the wrong password in there. So that's why it kept rejecting the connection to the network. And you can see all that kind of stuff. So it's really cool.
Yeah, I'll have to take a look at that. It's really hard to get hands-on information, like practice with DNA Center too.
Yeah, yeah. Hopefully they do something about that. I would love to see like a smaller scale VM that you could deploy and just to be able to play with it with like 1 or 2 switches.
Yep. All right, well, I am going to tap out if there's no more questions. Or it was nice to meet everyone. I think I know Eric already, but I don't think I met anyone else on here before. So, and I'll see you guys tonight as well. Hello, with I guess who was having a toast or something this evening?
Yes,
like
Tim Burt.
Happy hour. So yeah,
Yep.
I'll be there as well, or at least I'll try to be. So.
Perfect.
All right, have a good night or a good morning wherever you're from.
Awesome. Thank you so much. Have
Thank
a good
you,
one,
Andre.
guys.